In our previous lesson, we spoke at length about the multiplication of whole numbers and completed several examples to show many of the ins and outs of the process of multiplying. In this lesson, I want us to look at the opposite operation, which is known as division. It really is the case that multiplication and division are opposites of one another, just as addition and subtraction are opposites. So it's important that we're able to complete a lot of different kinds of division problems since they're so closely related to multiplication. Now, just as we did in our lesson on multiplication of whole numbers, let me take a few moments here to discuss what division of whole numbers really means. If I ask you to calculate 18 divided by 3, what am I really asking you to do? Well, imagine that I have 18 identical pieces of hard candy and I want to give them out evenly to 3 different people. How many pieces of candy will each person receive? Well, since 18 divided by 3 equals 6, it turns out that each person will receive 6 pieces of candy. It's that simple, and that's the main idea behind division. Now, just as with more complicated multiplication problems that I showed you in the end of the previous lesson, it turns out that division problems can often involve lots of steps and they can take several minutes to finish. But don't worry about that. Just learn the steps of the process, learn which steps to do when and how to do each one, and repeat that process every time you're faced with a division problem. So let's get started with a relatively straightforward long division problem. And by the way, they're called long division because they tend to go long on the page. Not a problem though. They really won't take that long once we work through all of the steps. So I want us to compute 86 divided by 2. We begin by setting up the problem using some notation which is unique to these division problems. We're going to start by drawing what is basically a right parenthesis followed by a horizontal line segment in the fashion that's on your screen. Then we're going to place the divisor, which in this case is the number 2, on the left side of that parenthesis. And we're going to place the dividend, as it's called, underneath the horizontal line segment. So we have our divisor on the outside and our dividend underneath the horizontal line segment. Now, unlike what we did with addition, subtraction, and multiplication in the previous lessons, in division we're going to work left to right. And the first thing we're going to ask is very straightforward. How many times does the divisor 2 go into or divide the 8 that I see in 86? Remember, I'm now going to be working left to right. So, how many times does 2 divide 8? Notice that I don't want to know how many times 2 divides the whole dividend, the 86. I just want to look at the relationship of the 2 with the 8. It's this whittling down process, this step-by-step process that's very, very important. So I just wanted to look at the 2 and the 8 at this point. I know that 2 divides 8 exactly 4 times, and that's because 2 times 4 equals 8. Notice here that it's very important as I'm doing division problems to know my multiplication facts. Here I needed to know that 2 times 4 equals 8. So now what do I do with that 4? Well, I'm going to write a 4 just above the horizontal line, and I'm going to make sure that I align that 4 vertically just above the 8. And that was because I was looking at the relationship between the 2 and the 8. The alignment here is going to be really, really important, just as it was with our previous operations. So at this point, I now have a 4 written above that horizontal line segment. By the way, the answer in all of these problems will always be what's written above that horizontal line segment. Now, since 2 times 4 equals 8, we write an 8 underneath the 8 in 86, and then we're going to subtract those two numbers, just the 8 minus the 8. When I subtract here, and it's always going to be subtraction there, that gives me 0. So I write down the 0 underneath there, and then I'm going to drop down the next digit that I see as I move left to right. In this case, the next digit in the dividend is the 6, and so the 6 is going to come down now as well. And so what I have now at the bottom of my page up to this point is 06, which of course I can just think of as 6. And now I'm going to repeat the process. And this is the idea behind all we've done in this course up to this point. There's a step-by-step process to go through, and now here I'm going to repeat. Now I'm going to ask myself, how many times does the 2, the divisor 2, divide the 6? And again, just ignore that 0 that's in front of the 6. It's really just 6 there. Well, 2 divides 6 exactly 3 times. Why 3? Because 2 times 3 equals 6. So I'm going to write a 3 in the answer section just above the 6. And then I'm going to write a 6 below the 6 at the bottom of our material. I'm writing that 6 there because 2 times 3 equals 6. And I subtract again. Again, it's a step-by-step process. Every time I get to this stage, I want to keep subtracting, subtracting, subtracting. And now I have a 0 down at the bottom of my work. And notice that we've worked our way through all of the digits in our dividend. We had the 8 and we had the 6, and we used both of them already. What does that mean? It means we stop. We're actually done with our problem. And the final answer is whatever is written above that horizontal line. In this case, it's 43. And so I can say then that 86 divided by 2 equals 43. Now this is really great if you think about it, but I'd really like to think, how can I check to make sure I got the right answer? It's always important to think about whether our answers are correct. Thankfully in mathematics, you can often check your answers, which I love about mathematics. There's always this feeling of security, if you will, if you know how to check your answers. Well, here's how you check an answer when you've done a division problem. You take the answer, in this case it's 43, and now you multiply it by 2. Why multiply? Because multiplication is the opposite of division. And if we've done our work correctly, 43 times 2 gives us 86, which was the original dividend. And if you use the skills that we learned in the previous lesson to multiply 43 times 2, you really will get 86. That's a check of our answer, and so we know that we've done everything correctly. Now, by the way, there's one more vocabulary term that we need to remember in these division problems. I've talked about the divisor, which was the 2 in the previous example, and the dividend, which was the 86 in the previous example. Here, the answer that we got, 43, has a special name. It's called the quotient of the 86 over 2. The quotient is the quantity that we obtain by dividing a dividend by the divisor. So the answers we're going to get in these long division problems are actually known as quotients. And I wanted to mention that to you just in case you saw that word in a textbook or some other source as you were working through these kinds of problems. Now, let's move to another straightforward example just to make sure we're confident with the steps that are going on. If you're already confident, why don't you try this example yourself and then check back with me to see if you got the right answer. Let's calculate 897 divided by 3. Okay, just as before, we're going to begin by setting up the problem very carefully. We're going to write that parenthesis. We're going to write that horizontal line. We're going to put our divisor of 3 outside of the parenthesis, way over to the left. And we're going to write that dividend, 897, underneath the horizontal line. And then we're going to start working our way one step at a time. Now, as before, we're going to ask ourselves, how many times does the 3, that's the divisor, go into the 8? I'm not going to ask how many times it goes into 897. It's too much to do at once. But I can just check how many times does 3 go into 8? Well, you might say to me, wait a minute, 3 doesn't divide 8 evenly. So it's going to mess us up, right? No, actually everything is going to work out fine. I don't need the 3 to divide the 8 evenly. I just need to know how many 3's can I take out of 8. You can even think of it this way. How many 3's can you subtract from 8? Well, the answer is 2, because 3 times 2 is 6, which is less than 8, and 3 times 3 is 9, which is too much. So I know that 3 will go into 8 2 times. So I'm going to write that 2 above the 8 on that horizontal line segment, which is basically my answer section. Now, 3 times 2 is just 6, so I'm going to write a 6 below the 8 because that 3 times 2 equals 6. Now, do you remember what I do at this stage? That's exactly right. I'm going to subtract. And when I subtract 8 minus 6, I'm going to have 2. Now, let me just point out, in this problem alone, we've used a little bit of multiplication and we've used some subtraction. So this mathematics is still building on itself as we go one step at a time through these new kinds of problems. Now, we've subtracted, we have a 2. What's the next thing we're going to do? We're going to drop down the next digit in our dividend, which we haven't looked at yet. In this case, that's the 9. So I'm going to drop down the 9 next to the 2, and at the bottom of my work, I should now have a 29. Notice again, neatness and being careful with my alignment is going to be very important as I work through these problems. Now I have a 29 at the bottom of my work, and now I go through the same step again. How many times can 3 come out of 29? Or how many times does 3 divide 29? Well, there's going to be 9 times that 3 can come out of 29 because 3 times 9 is 27, which is less than the 29. But 3 times the next number up, or 3 times 10, is 30, which is more than 29. So now I'm going to work with the 9 in the 3 times 9. There are 9 3's in the number 29. Let's write that 9 above the 9 in the dividend, and that's going to be part of my answer. And then I'm going to write a 27, since 3 times 9 is 27, underneath the 29 at the bottom of my work. And now I look at the bottom of my work. What do? I subtract again. 29 minus 27 is equal to 2. So I drop that down at the next line, if you will, of my work, and I have a 2. Now what do? I go to the dividend again and look for the next digit that has not been used yet. The 8 has been used and the 9 has been used, but the 7 has not. And so I drop my 7 down to the bottom of my work, and that means at the bottom I now have 27. You see why these are called long division? The work starts to get long. It's not complicated, but it is kind of long as we work through the steps. And now we ask the same exact question again. How many times does 3 go into 27? Well, here, 3 goes into 27 exactly 9 times because 3 times 9 is 27. And so, above the 7 that I have in 897, I'm going to write a 9 in the answer section. Since 3 times 9 equals 27, I'm going to write a 27 at the bottom of my work again, and I'm going to have 27 minus 27. Again, I have to do the subtraction, and I'm down to an answer of 0 at the bottom, if you will, at the bottom of my work. Now, notice that we've used all of the digits in the dividend, the 8, the 9, and the 7. And we have this 0 at the very bottom of our work. And that is a hint that we are done, that we need to stop at this point, and we actually know our answer. Our answer is 299. That's what's in the answer section at the top. And so I can say that 897 divided by 3 equals 299. And that means, in a really crazy sort of way, if I were to take 897 identical pieces of hard candy and give them to 3 different children, and give them each as much as possible, then each child will receive exactly 299 pieces of candy. Of course, I'd have to deal with a big dental bill at that point, but I don't want to think about that at this point. That's just one interpretation for that division problem. Now, how do we check our answer to see if it's correct? Well, the way to do that is to multiply the answer, the quotient 299, by the divisor 3. And if you go back to our previous lesson and you check 299 times 3, you will get 897 if you just work through the steps. and that was the original dividend. And that tells us without a doubt that we've done that long division problem correctly. Now, I'd like to look at a slightly larger example just to make sure that we can work through these steps one step at a time to calculate these kinds of division problems. So here's the example. Calculate 2,905 divided by 7. Now, some of you might be a bit concerned about the 0 that's in 2,905. Really, it's not a problem at all. Just work through the problem with me as we go through, just like we did in the previous examples, and I think you'll find that that 0 isn't going to hurt us at all. So we're going to start by setting up our problem, writing our parenthesis, writing our horizontal line, writing the 7 outside, that's our divisor, writing 2,905 underneath the horizontal line. Now, we begin the process in the usual sort of way. I look at my 7 and I'm going to ask, how many times does 7 go into the 2? Well, actually 7 is bigger than 2, and so I feel a little stuck here. I don't see what to do. Well, I'm not stuck at all. What I do is I say to myself, how many times does 7 not just go into 2, but how many times can it go into 29? I'm going to use the first 2 digits of my dividend if I need to, because the 7 was too big for the 2 in the first place. So how many times does 7 go into 29? Well, there are 4 7s in 29, because 4 times 7 is 28, which is smaller than 29, but 5 times 7 is 35, which is too big compared to 29. And again, notice how I've got to be able to do these multiplication facts on the fly. I need to be able to do them quickly in order to handle these long division problems. Okay, there are 4 7s in 29, and so I'm going to write a 4 above the 9 in 2,905, and I'm putting it above the 9 because I used that 9 to write down 29, if you will, okay? And now I'm going to write a 28 underneath the 29. Where does the 28 come from? It's 4 times 7 equals 28. Now what do? I subtract. I subtract all the time when I get to this stage. 29 minus 28 is just 1. So I leave that 1 there, and then I drop down the next digit in the dividend. Now I've already used the 2, and I've already used the 9 in the dividend, so the next digit that I want to drop down, if you will, is the 0. And that's what I drop down. And now at the bottom of my work, I have a 10. No problem at all. And now I'm going to ask the same question that I've asked before. How many 7s can I get out of that 10? Well, just 1, because I know that 1 times 7 is 7, which is fine, but 2 times 7 is 14, which is too much. So I'm going to place a 1 above that 0 in 2,905. And since 1 times 7 is 7, I'm going to place a 7 under the 10 at the bottom of my work, and I'm going to align it correctly. And now I need to subtract. 10 minus 7 is equal to 3, so I leave that 3 there, and then I drop down the next digit that I haven't used yet. I've already used the 2, I've used the 9, and I've used the 0, but I have not used the 5. And so I'm going to drop down a 5, and that means at the bottom of my work, I now have the number 35. And now I ask the same question again. How many 7s are there in 35? Well, if I know my multiplication facts quickly, I know that there are 5 7s in 35, because 7 times 5 equals 35. So I write a 5 in my answer after the 4 and the 1 that are already there, and I place a 35 underneath the 35 at the bottom of my work, since 5 times 7 equals 35. Subtraction of those two 35s is going to just give me 0. 35 minus 35 is 0. And there are no more digits to use in the dividend. I've dropped them all down. And that means I'm done. And that means I can read my answer immediately from above the horizontal line. My answer is 415. Now, remember, if you want to check your answer, you would multiply the original divisor, which is 7 in this case, by the quotient that you just found, 415. And you would check to make sure that 415 times 7 gives you the original dividend, which is 2,905. Now, I can imagine some of you saying, wait a minute, you've been rigging these problems so that they always end up with a 0 at the end of the problem, at the bottom of the work, if you will. Now, does that always happen? And if it doesn't always happen, what do? I don't want to be stuck if I don't end up with a 0 at the bottom of the work. Well, if you thought of that question, I congratulate you for noticing that, because actually that only happens when you're really careful about setting up the original problem. I really have been setting up those problems so that they worked out pretty cleanly. So at this point, I'd like to do an example where the numbers don't work out so clean at the very end, where you end up with something other than a 0 at the very bottom of your work. It turns out that that's not a bad thing to happen. It's actually a pretty natural thing to happen, but I'd like to show you how to interpret that kind of a problem. So, with that said, let's calculate 578 divided by 6. Now, we're going to start this problem just like we've started all of the other problems in this lesson. We've got to set up our problem with the parenthesis and the horizontal line. We put our dividend of 578 underneath the horizontal line, and we put our divisor of 6 out in front. Okay, we're going to work through the problem just as we have with the other problems by asking ourselves, how many times can 6 come out of the first digit, which in this case is a 5? Well, 5 is too small. 5 is smaller than 6, and so the 6 cannot come out of the 5 or be subtracted from the 5 in this case. So do you remember what we do? We just give ourselves another digit. We have that flexibility, and so now what we ask instead is, how many times can 6 be subtracted from 57? We give ourselves the first 2 digits to work with. Well, you may have to work through some of the possible multiplications here, but after a while you should find that 6 can be subtracted from 57 9 times. And that's because 6 times 9 is 54, which is just a little smaller than 57. But 6 times the next number up, which is 10, is 60. 6 times 10 is 60, and that's too big. You only had 57 to work with, not 60. So we want to say that 6 comes out of 57 9 times. We write a 9 above the 7, and we write a 54 below the 57. Remember, 54 was the 6 times 9. And now we subtract. 57 minus 54 gives us 3. So what do we do next? We drop down the next digit in the dividend, which we haven't used. But we've already used the 5, and we've already used the 7. And that means we want to drop down now the 8, which is the next digit in the dividend. That leaves me now at the bottom of my work with 38. And so I now ask the same question again. How many times does 6 go into 38? Well, the answer is 6. Again, I've got to think about my multiplication facts here. But 6 times 6 is 36, which is less than 38. And 6 times 7 is 42, which is bigger than 38. And again, you've got to know these multiplication facts. You've got to be able to do this quickly, or these long division problems will take forever, and they'll get frustrating. So make sure you're working on those facts as you walk through this course. Now, since 6 goes into 38 exactly 6 times, I'm going to write a 6 above in the answer line, if you will, in the quotient line, and I'm going to write that 6 just above the 8 that's in the dividend, because that's the digit the last digit I've used up to this point. Then I'm going to write a 36 under the 38, since 6 times 6 equals 36. And now I'm going to subtract, just as I've been doing all of these problems, and that gives me a 2 at the bottom of my work. Now, the next thing I would do, if you think about it for a moment, would be to drop down the next digit in the dividend that I haven't used yet. That's what we've been doing through all these problems. Except we have a problem here because I don't have any more digits to use. I used all of the digits in the original dividend. So what do? I mean, there's a 2 at the bottom of my work. Well, it turns out that that 2 is supposed to be there. And since the 2 is less than the divisor of 6, we're actually going to stop at this point. There are no more digits to drop down, and the amount at the bottom is less than the original divisor. So we're going to stop. But what does that mean exactly? How do we interpret the information that's now sitting in front of us? Well, first of all, I can tell you that our final answer is easy to write down. It's 96, which we have in our answer, with a remainder of 2. That's actually a perfectly valid answer, 96 with a remainder of 2. But how do we actually interpret that kind of answer? Because now we have this 2 at the bottom. Well, here's one interpretation. First off, 6 does not evenly divide the number 578. So no problem there. But to use our candy analogy, we could say something like this. If I had 578 identical pieces of hard candy, and I distributed them evenly to 6 children, then each child would receive exactly 96 pieces of candy. Okay? But then there's a little twist here. We would have 2 leftover pieces of candy. That's where that remainder comes into play. I'm not sure what we would do with those 2 pieces of candy if we were trying to give each child the same amount. And so the 2 pieces are sort of like leftovers, if you will. Other than that, we could divide up the candy evenly amongst the children by giving them each 96 pieces. You and I might have to split those other 2 pieces, which would be sort of the extras. Now, let me make another comment here. How do you check your answer in a case where there's this 2 at the bottom, which is like a non-zero remainder? Well, it's actually no problem at all. As before, you would just start by multiplying the divisor, in this case the 6, by the quotient, which is 96 in this case. And if you do that multiplication, you'll have 96 times 6, which is 576. Okay? Now what you do to finish is you add that extra remainder in to see if you get the original dividend. And if you take the 576 plus the 2, which was that remainder, you get 578, and that was the original dividend. And that is how you confirm that you've done the problem correctly. Now, we're definitely going to spend some more time on these kinds of problems, and in fact, I would like to show you one last problem where we have a little more of a difference in the divisor, if you will, but I want to make sure that you continue to think about long division for a while. So we're going to talk about division later on with fractions and decimals as well. But to close out this lesson, I'd like to show you one more example where we work through a long division problem. Actually, it won't take that long, but there is a new twist in this example, so let me show it to you here. I would like to divide 276 by the number 12. Now, what's different about this problem? Well, I'm giving you a divisor now that actually has 2 digits. That would be the number 12 in this example. Now, you might say, well, I can't do that. Actually, you can. It's really not a problem at all. It's the same as the other kinds of problems, and so let's work through it together. You set up the problem, draw your parenthesis, draw your horizontal line, put the 276 under the horizontal line, and put that 12, that's your divisor now, out to the left. And now you just work through the steps. 12 goes into the 2 how many times? Well, the 2 is too small. So you give yourself another digit. 12 goes into 27 how many times? 12 can be subtracted from 27 exactly 2 times. And so we're going to write that 2 above the 27, above the 7 in 27. We've got to get our alignment correctly. And then we're going to take 12 times 2. This is where knowing your facts up to 12 times 12 can be very helpful. 12 times 2 is 24. So we're going to put the 24 down below the 27, and we're going to do what operation? We're going to subtract. 27 minus 24 is equal to 3. Now what do we do next? We take the next digit in our dividend and we drop it down. Well, we've already used the 2, we've already used the 7, so all we have left is the 6. We drop that 6 down, and now we have 36 at the bottom of our work, and we ask ourselves, how many times does the 12 go into or divide the 36? Well, if you know your multiplication facts, you know pretty quickly that 12 times 3 equals 36. So we're going to write that 3 up above the 6 in the dividend, and we're going to have a 3 in our answer section. 12 times 3 is 36, so we put a 36 at the bottom of our work. 36 minus 36 is 0, and we have no more digits to drop down because we used the 2, the 7, and the 6 already, and we have our final answer. Our final answer is that 276 divided by 12 is exactly equal to 23 with 0 remainder. Now, over the last few lessons, we've taken the time to review how the operations of addition, subtraction, multiplication, and division work with whole numbers. These are important skills to build, so I encourage you to make sure that you have these down pretty solidly before you move forward. Once you're ready to do so, I invite you to join me for the next lesson as we take an introductory look at fractions. I look forward to talking with you then.